Hi, in this lecture video, I'll be discussing the conservation of mass in chemical reactions. So in a chemical reaction, a substance is being converted into other substances. And the initial identity of the substance are then referred to as the reactants. And what this reactant becomes, we would then call them the products. And if we were to have a chemical reaction, we can further describe that by writing a chemical equation, where the reactant are then listed on the left side of this chemical equation, and the product are then listed on the right side of the products. For an example, for the chemical reaction, the electrical decomposition of water into hydrogen and oxygen gases. So in this reaction here, we can see that water is being converted into hydrogen and oxygen. And to write the chemical equation for this, water in this case right here would then be the reactant, since we started out with it. So water would then be on the reactant side. And now on the product side, it would then be the hydrogen and the oxygen gases. So this would be the reactant. And everything, all of the reactant will be listed on the left side of this chemical equation. So this is the chemical arrow right here. And this arrow means chain. And now the products are then listed on the right side of this chemical arrow. So the left side and right side would then be the product. And in this case, this is a chemical chain, right? Because we can see the formula of a reactant and the formulas of the product are not the same thing. So therefore, one substance is being converted into, in this case, two other substances. So this is then a chemical chain. And again, a chemical chain is a chemical reaction. And in a chemical reaction, the mass of matters are being conserved. So in a chemical reaction, neither the mass of matter is neither created or destroyed, and therefore their masses remain constant. This is then known as the law of conservation of mass. So the combined mass of all of the reactant must equal to the combined mass of all of the product. For an example, if we were to have 36 grams of water, and when we decompose this into hydrogen and oxygen, we're supposed to form 36 grams of the product as well, in which 4 grams of this would then be hydrogen and 32 grams of this will be oxygen. But adding together, it would still equal to 36 grams. So 36 grams of reactant become 36 grams of the products. So the mass must remain the same. And the reason for this is because in the course of a chemical reaction, the atoms simply get rearranged, but the atoms are not getting created or destroyed. But then the bonds between the atoms are being broken to form new bonds. So in a way, the atoms get rearranged to form all chemical substances. Okay, and this mass conservation here can be explained by this theory. All matter are made up of atoms. In a chemical reaction, the atoms have rearranged. For an example, here in this case, we have 2 water molecules. So 2 water molecules. Here's 1 water molecule, and here the other. And in the course of chemical reaction, it is being broken into hydrogen and oxygen gases. So if we think about this, it is as follows. We would have these 2 hydrogen right here. In the course of this reaction, they get combined together. Initially, this hydrogen and this oxygen are bonded together, but now that bond is broken, and these 2 hydrogen are now coming together to form the first H2 molecule. And the oxygen in the middle are then bonded together to now form O2, and the other 2 hydrogen are now bonded together. So as you can see, the bonds are being broken and new bonds are formed. But we are not destroying the atoms or creating a new atom. But the atoms simply get rearranged to produce the new product. So we can see that on the reactant side, we have 4 H atoms altogether, and we have 2 oxygen atoms altogether. Now on the product side, we have 4 H atoms here, and 2 oxygen atom right here. So the amount of atom remain the same, and therefore the mass must remain the same as well when we go from reactant into the product side. And that is the law of conservation of mass in chemical reaction. So now let's try an example right here. Suppose we have 12 grams of natural gas combined with 40 grams of oxygen in a flame. So we burn this natural gas. Then this chemical reaction here produces 33 grams of carbon dioxide. So how many grams of water must be formed then? When we take natural gas and we combine that with oxygen, it will be converted into CO2 and water. So here in this case right here, we have 12 grams of natural gas and we have 48 grams of oxygen. If we will combine together, then we have 60 grams of reactant. Alright, and now on the product side, we are producing 33 grams of carbon dioxide. So how many grams of this of water should we produce? And notice again that if we have 60 grams of reactant, we also need to produce 60 grams of the product as well. So that tells us in this case right here, there has to be 27 grams of water that getting produces as well. Please try this following example to make sure you know and understand the law of conservation of mass in chemical reaction.